Okay, so as a sample for the concept of two-step irreversible reaction in series, we will now be solving 3.14, problem 3.14 from Octave Levenspiegel's book of Chemical Reaction Engineering. You are given here a series reaction starting with species A, having intermediate R, and final product S. Now, this scenario is quite different than the one that we had in the book, where a series of formulas were derived, formulas that will determine the concentration of A, R, and S at any particular time in the course of the reaction. Now, in that particular scenario, your rate constants for the first and the second, or the first and the second step in your series reactions are not equal. Now, in this case, the two rate constants are said to be equal, and at time equal to 0, there is no presence of the intermediate R and final product S. Now, at this condition, at time equal to 0, we have the initial concentration of A being presented as CaO. Now, for this same problem, actually it required the same requirement as the formula that was presented in the book. So it's asking for the maximum concentration of R, that is the intermediate, and when was this particular maximum concentration reached. So it follows then, class, that this particular problem would allow you to check whether in principle you were able to, or you can apply the principles discussed in the derivation of the different formulas in determining the concentration of A, R, and S after some time. Now in here we have to totally find a new set of formula because the condition wherein your rate constants are said to be equal. Now, in that particular set of formula we've discussed last Monday, the rate constants are not, shall I say, equal. Okay, so we will go to our whiteboard. Okay, for 3.14, you're given a series reaction with these rate constants, and K1 and K2 are said to be equal. Ca is equal to CaO at time equal to 0, and your CRO and CSO are all 0. So the O subscript here, or the 0 subscripts, implies that we are determining the concentration of the two when time is equal to 0, or that's at the start of the reaction. So we are to work with this given information, and you are required for the maximum concentration of the intermediate R and the T when C sub R is C sub R maximum, or what's the time when C sub R is maximum. Now, actually, we're going to use the same set of procedure that was applied in determining the three formulas discussed in the book. So we will try to find first the concentration of A at any particular time. So I'm writing it here, just like that, the rate in terms of A being equal to K sub 1, C sub A. Now we're only focusing this in this case, since this is our first DE, we're only focusing on the first step because it allows us to determine the concentration of A after some time. Now working on this formula, so just like what we did last meeting, just as a review, this will be also review. And substituting the appropriate limits, CaO for initial concentration, and of course you have 0 to T for the limit of time. The left side here will be negative ln of Ca over CaO. and the right side will be k sub 1 t. Now, if we transfer the negative in here and make both sides of the equation the argument of E, what is left here on the left side is CA over CAO. And in here, you will have an E raised to negative K sub 1T. So the formula that we had for the first scenario wherein K sub 1 and K sub 2 are not equal, in determining the concentration of A after some time is still the same. So this is CaO E raised to negative K sub 1 T. So this is our first um, equation. Okay, let me check my battery. 24 minutes. I will pause recording here for now, class. I will try to check whether I have transferred my files properly so I can transfer